So the first question is about a distribution, and we would like to get an estimate of the probability between a certain range. So the first one, okay, you have x. The mean is equal to 180. The variance is equal to 25. Okay, so randomly choose 25 packs. Okay, randomly choose 25 packs. What is the probability that the mean weight, okay, the mean weight falls between 170 and 190? So it is probability of x bar, right? Because it is mean weight, right? X bar. So x bar will be between 190 and 170, right? Okay? And so here, because the question tells us is about x, and what the question asks is about x bar, so you have to transform this distribution into x bar. So if this is the case, then we know x bar has a mean 180, right? And what about the variance? The variance is sigma x squared divided by n, right? So sigma x squared is equal to 25. Divided by n, n is also equal to 25, right? So that is 1. Okay? And so in this case, t is equal to 170, okay? Minus 180, that's going to equal to x bar minus 180, right? That's going to equal to 190 minus 180, okay? So then what you get? T negative 10, that's going to equal to x bar minus 180, that's going to equal to 10, okay? So what do you have? You have T x bar minus 180, okay, less than or equal to 10 times 1. Okay, so here the variance is 1 and the standard deviation is also equal to 1. So here it is k and here it is sigma x, right? Must be greater than or equal to 1 minus 1 over 10 squared. So that should be equal to 0.99. So for the first question, the answer is 0.99. Okay? Because the point that you need to be very careful about is here. They talk about mean weight. Okay, the mean weight. Okay? The second question, suppose the distribution is normal. So here we do not specify, what kind of distribution it is. So we have to use Chebyshev inequality. And now you know that this is normal distribution, so you have to use normal. Okay? So you have T, okay, 170 less than equal to x bar less than equal to 190. And then you have probability, okay? You have to transform this one into z. Okay? So then it is 190 minus 180. Okay, here. 180 is the mean, okay? 190 minus 180 divided by 1, okay? And then it is 170 minus 180 divided by 1, okay? And so then what you get? You get t negative 10 less than equal to z less than equal to 10. So as you may know, if it is 3 here, minus 3 here, what you get? 0.9 or something, right? But what about here? It is 10, it is negative 10. So what is the probability? It is equal to 1. So for those you put down 0.954 is wrong. Okay, it should be here. The probability is equal to 1. Okay, questions. The next question will be a little bit more complicated, okay? So let us be more patient in dealing with the question. Any question with the first one? Okay? Okay, let's get to the second question. So you have X and Y. So X distance you have 1,000 students. Okay? For Y you have how many? 2,000, right? Okay? And the distribution is X normal, okay, 165, variance 25, Y normal 170 and 36. Okay? So how many you choose? We choose 100 students from X. So NX, okay? NX is equal to 100, right? And NY is equal to 64. Okay? Then the question tells you that what is the probability that the mean weight of the students of X will be 10 centimeters taller than that from Y? Okay? So we are talking about the mean weight. Okay, we are talking about mean weight. So X bar minus Y bar greater than or equal to 10, right? So we are talking about this probability, right? So in this case, you need to know what is the distribution of X bar, right? For X bar, it's going to be normal 165, and how many people you choose? You choose 100, right? So that is 1/4, okay? And for Y bar, how many people you choose? You choose 64. So that is 170 and 36 divided by 64. Okay? So basically the same thing. You have the first information about the distribution here and the number of students. Okay? And now how many people you choose from each? From X, 100 students. From Y, 64 students. And so you have a distribution of the sample mean. Okay, this is sample mean distribution. And so here, you have to translate the question into a formula. Okay, so this is the question and this is the formula. Okay, and so, we are going to calculate the probability, right? So P, okay. So what we need to do is, of course, we are talking about X bar minus Y bar, right? So you need to know what is the distribution of X bar minus Y bar. X bar minus Y bar. What is that equal to? X bar minus Y bar, you have mu X minus mu Y, right? So that is -5. And what about variance? Okay, Mr. Chen, what about variance? What should that be? Okay, so it is this one plus this one, right? Okay, 1/4 plus 36 over 64. Okay, so, basically we have an assumption say, these two populations are independent. Okay, these two populations are independent. Okay, so you have to transform this one into Z, right? Z. Okay, greater than or equal to 10. So here you have 10 minus -5, right? Okay, 10 minus -5, because here is negative. And what about here? It is square root. Okay, it is square root 1/4 plus 36 over 64. Okay, so as you can see, this is a number smaller than 1, right? This is a number smaller than 1. What about this number? It is 15. If Z greater than 15, okay, can anyone tell me what is the probability? It is 0, right? Probably, when Z greater than 3 or 3.5, it is close to 0. And 15 is even larger. And what about this number? Much larger than 15, right? So what can you see? What's the probability here? It is equal to 0. It will never happen. Okay, question. Then let us talk about the second one. Is that right? Second one say, how many people will fall between 160 and 170? Okay? Okay, so this question is different. Can I erase this? Okay, let me put it here. For the second question, we are talking about probability of X between 160 and 170, right? And probability of Y between 160 and 170. Okay? So basically, this is the simplest question. Okay? You transform these two into Z, then it is done. Okay? Question on this. Or should I, if you would like me to do it again, please raise your hand. Anyone? Mr. Yang, would you like me to do this again? No, it's fine. Okay, good. So basically, the way to do this question, the same thing, transform that into Z, right? Okay. Then let us get to the next one, because the next one is a little bit more difficult. The next one say, okay, now you're going to pool, okay? Pool means put them together. Okay, pool. For example, there's a term called carpool. What means carpool? It is not about a car that has a swimming pool. It is not the case. Carpool means that you use the car together. So for example, I live in, let us say I live in the downtown area, okay? And suppose Wang Zi also live in downtown area. And, we take turns driving, okay? We get into, so for this week, I drive, okay, in my car. And for the next week, she drives, and I'm the passenger, and she drives. We use use her car. So that is the way we call carpool. So some people, get together, use the same car. Okay, this is called carpool. Anyway, and this pool means put the two populations together. Okay, question. Can I erase it? Okay. Okay, now we want to put these two groups of people together, okay? So if you look at question 6, an airline is recruiting and only 50% of the students from X and Y around the median height can apply, okay? What is the range of that height? First, you need to know what's this group, okay? So, what's this group? It is this group of people, okay, around the mean. Okay, you put these two groups, this 1,000 and these 2,000 people together, okay, and then you are looking for some of the people here around the mean, okay, around the mean. So here you have 0.25, and here you also have 0.25, okay. But for the first group, the mean is 165. For the second group, the mean is 170. But what about a new population? So you need to calculate the new population. So the mean is equal to, okay, nx times mu x plus ny times mu y divided by nx plus ny. Okay? Because now you have 1,000 people plus 2,000 people. This is the size of the population. And what is the mean of this one? It should be here, okay? Because nx times mu x is equal to nx times 1 over nx times summation xi, right? And ny times mu y is equal to ny times 1 over ny summation yi. Okay? So this is the way to get the new population mean. Okay, this is the way to get population mean. And what about the population variance? So here it is a little bit more difficult here. So you have sigma x squared is equal to 1 over nx times summation xi squared minus mu x squared, right? And then you have sigma y squared is equal to 1 over ny times summation y I squared minus mu y squared. Okay? But here what you need to get is the new sigma squared. And what is that equal to? Actually, that is equal to nx times sigma x squared, okay, plus ny times sigma y squared, okay, and then you got to divide it by nx plus ny, and then minus mu squared, okay. So basically, this is what you get, okay. Hold on, let me think about it. I think there's something missing here. So in this case, you have summation xi squared is equal to sigma x squared, okay, it should be nx, okay, times sigma x squared, right? We are looking at this part, okay? So first we have to times both sides by nx, okay? So you have nx sigma squared, and here you have to move this to the other side, right? Plus nx times mu x squared, okay? So basically what you need is to have nx plus sigma x squared, okay, plus, okay, nx times mu x squared, and then plus ny times sigma y squared plus ny times mu y squared, and then divided by nx plus ny minus mu squared. Okay, so here you basically just plug in the formula. Okay, so if you remember the day before the second exam, we discussed it, right? We discussed this question. So basically, you apply the formula there, this will be fine. Okay, and the question is, of course, you are looking for this part. Okay, so then, in terms of calculation, it is a little bit cumbersome. Okay, a little bit cumbersome. Let me tell you what's going on here. So anyway, if you get the new population mean, okay, so here the new population. For the new population, the mean is equal to 168.33. And the variance is equal to 39.02. Okay? So here is what you get. For the mean, you get this, and for the variance, you get this. Okay? And of course, if you have information about the mean and about variance, and also you know that this is a normal distribution, right? This is a normal distribution. And so, can anyone tell me what's the z here? The corresponding z. What is the corresponding z when the probability is equal to 0.25? Anyone got a book? Okay, anyway, you can check this, right? You can check it. You got a table. Okay, 0.25. So where is it? 0.275? Okay, 0.67, okay? So basically, you have this. T, okay, you are not sure about this. Z greater than 0.67, right? Less than negative 0.67, okay? So from here, okay, then what can you see? Can I erase this now? Can I erase this part now? Yes or no? Yes, can. Okay. And so, in this case, Z, okay, you have 0.67 is equal to X. So here you are looking for the new variable, let it be X, or we may get some confusion there. So here, let the new variable be X, okay, so X minus 168.33, and then divided by, okay, 39.02 square root. So from here you can get X, okay, this value here and this value there. So the answer is 164.12 to 172.54. Okay? So basically, if you know normal distribution, the zip code part, okay, the zip code part is to combine these two populations together, right? The zip code part is here, but we discussed this right before second attempt. Okay, we discussed this part right before second attempt. Any questions? So then let's get to part 3. Okay, part 3 we have, according to a... Really? I think this is right. Okay. If you have any question, we discuss it at the time. Okay. I believe this is right. Okay. Let us get to the third question. Okay. The third question, basically this is binomial distribution, right? So you have 80% of the people got flu, and randomly choose 196 person, and S is the number of the people that got flu. What is the probability function for S? Okay, so since we know that it is a binomial distribution, we are talking about S is equal to N, right? And then it is how many? 196 people, right? And S, okay? S is the number of people that got flu. And the probability is 0.8 S, and here is 0.2, 196 minus S. Okay? Questions so far? The second one, we talk about what is the probability that exactly 10 people got flu. So exactly 10, S is equal to 10, right? So you put 10 here. So then it is T, S equal to 10, equal to 196, 10, 0.8, 10 power, 0.2, 186 pounds. Okay? Question. And the next question, what is the probability that between 36 and 54 people got flu? Okay, so P, 36 and 54. Okay? So between 36 and 54. So here you have to add something more, okay? Because now you have several people, right? So you have, several kinds of S. So you have summation, right? S from 36 to 54. Okay, and then you have 196 S and 0.8 to S power, 0.2 to 196 minus S power. Okay? Questions? The last one. So the probability that 0.4 to 0.8 of the people, 40% to 80% of the people got flu, right? So then you have to know how many is 40% is corresponding to how many people, right? So 0.4 times 196. Can anyone tell me what's the number here? Got a calculator? And 0.8 How many? Okay, 78.4, and this would be 8, 6, 15, right? Okay, so 156.80. So that is basically, the way to go. But what's wrong with this? Can you use binomial now? No, right? In this case, you have to use normal distribution. Okay, so basically, you use normal distribution and you can get the answer. The last question is another easy question, right? Because it said no one-cut fluid. No one-cut fluid means this is equal to 0, right? Okay, so this is equal to 0. Okay. And also this is equal to 0, right? And then this is equal to 0. Okay? So basically we plug in the number. So if you remember something about binomial distribution, you should be able to get it. Okay? Because in this case you are not required to calculate. Okay, so if you can put down the formula, that's just done. Okay, questions? Okay, now we get to another question. It is about population mean, and it is interval estimate. Interval estimating. Question. Okay, let's get to the second one. So, basically 80% of the people like to jog. Okay, they like jogging. And then you are required to get a 95% confidence interval, right? So 0.8 plus minus 1.96. Because this is a two-sided test. Two-sided estimation. So then you have plus, and then you have 0.8 times 0.2 divided by how many? 64, right? So basically, if you can get this, you're done, okay? So that is for question 4. Any questions? Let us get to the next one. So Ford produces 2 million cars a year. On average, a car lasts 9 years, and the standard deviation is 3 years. Okay, so you have something like this, okay? The mean is 9 years, okay? The standard deviation is 3 years. And you hope that, here you said that the guarantee is 3 years. So the warranty, factory warranty is 3 years. And so for these cars, you may have to repair them. Okay, for these cars you may have to repair them. So in this case, what is the probability? So how many cars? So the question says how many cars you expect to repair them for free, right? So here, what you can get is the probability. And if you want to get the number, you have to times that by 2 million. Okay, so first you are going to calculate x less than 3, right? What is the probability that x is going to be less than 3? And you turn this into z, right? Z less than 3 minus 9, okay? And what is the standard deviation? Standard deviation is equal to 3. But how many cars? Okay, there's no random sampling, so it is 3z. So that means Tz less than negative 2, right? Okay? And what about negative 2? So what is the probability here? 0. How much is that? What is the probability? Let me get it here. So that is question 3, right? 0.0228. Okay, 0.0228. So then 0.0228. How many cars Ford produces? It is 2 million, right? Times 0.0228. So that is 456. So that is 45,600 cars. Okay, so they are expected to retail this many cars for free. Okay? Questions? Let us get to the next one. The next one is about the estimation of the price of books. Okay? The estimation of the price of books. So then you have $500, that is the mean price. Okay, the average price is 500, and the standard deviation is 70. Okay, and you are going to get the 90% confidence interval, right? So it is 500 plus 1 plus minus 1.64, and then standard deviation is 70. How many books you get? 49. So that is divided by 7, right? Okay, so basically that is the answer for question 6. Okay, question 6. Any question? No. Very good. Yes. Okay, good. Now let's get to the question 7. Okay, question 7 is a little bit difficult here. Okay, first one you have mu is equal to 1 over n minus 1 divided by 2, okay? And then you have summation I from 1 to n plus 1 xi, okay? So this is for mu 1. And then mu 2, it is 1 over m plus 1 divided by 2. And here you have summation I1 m minus 1 plus 1. And here you have n, okay, xi. So as you can see, we have done this question before. The most important thing is to get the number right, okay? And the question says n is an odd number. N is an odd number. Okay? So basically you need to figure out what's the number here and what's the number here. Okay? So then what can you do? So actually here you have n minus 1 divided by 2, summation I from 1 to, right? Okay? So here you have n minus 1 divided by 2. And here you have from 1. So you can manipulate something here. So as a matter of fact, n plus 1 divided by 2 is equal to n minus 1 divided by 2 plus 1. Okay? So how many here? Sorry, we had to put. So in terms of number, the denominator is 1 minus 1 over 2. What about numerator? So how many xi do you have? How many xi? As a matter of fact, you know xi is equal to n, because here, the first one, this is the first one, this is the last one. So if you are going to calculate a number, right? So this one minus this one, right? And then, so you have this one minus this one. So that means, okay? And because this one is counted, and this one must be counted too, right? So then what you get? You get that here, actually, you have to also add 1 too, because this one is counted just like counting trees, okay? 1, 2, 3, 4, 5, right? How many trees do you have? Okay? As a matter of fact, it is, the total number is equal to 5, right? But when you 5 minus 1, okay? 5 minus 1, you only get 4. So as a matter of fact, you have to add another one, right? So that add 1. So this is the same thing. Here is the last number. Okay, minus 1 it is here. But as a matter of fact, you have to add 1 here. Okay, so what you get? You get the total number of the xi. Okay, the number of xi is equal to n plus 1 divided by 2. Okay, here it is n plus 1 divided by 2. Okay, let's look at this one. So what does that mean? That means when you get expectation. So you're going to get expectation of mu1. Okay, if you get expectation of mu1, what you're going to get? You're going to get that is equal to 1 divided n minus 1 times n plus 1 divided by 2 times mu x. So in this case, is it an unbiased estimator? No, it is biased because this one is not equal to mu x. Okay, so it is not an unbiased estimator. It is biased. Okay, it is a biased estimator. What about this one? Okay, the same thing, right? So you have n minus 1 plus 1. Okay, minus 1. Okay, but you have to add 1 here. Okay, so then what you get? The total number is n plus 1 divided by 2. Okay, so the total number here is n plus 1 divided by 2. N is the last number. Here is the first number. And of course, because this one is counted, and this one is also counted, so you have to add another one. Okay, and what about here? The denominator is also equal to n plus 1 divided by 2. And also this is n plus 1 divided by 2. So when you calculate the expectation, what is going to be? It's going to be 1 over n plus 1 divided by 2 times 1 plus 1 divided by 2 times mu x. So that is equal to mu x. Okay? So the first one is not unbiased. So it is a biased estimator. But for the second one, it is unbiased estimator. Let us take a break. You know, when the first question is talking about whether it is a unbiased estimator or not. And so in this case, you know that mu1 is biased and mu2 is unbiased. And then which one is better? Okay, which one is better? Then you have to calculate MSE. Okay. So which one is better? So you will have to get to MSE. And FE theta hat actually has two parts. The first part is variance of theta hat, right? The second part is the bias theta hat square. Okay? So basically, in terms of variance, if you look at the denominator, if you look at the denominator, you already know which one has a larger variance. Okay, in this case, the denominator is smaller, right? If the denominator is smaller, what does that mean? The whole thing will be larger, okay? And here, the same thing. And also, the first one is biased, right? The first one is biased. What about the second one? The second one is unbiased. So which one is better? The second one is better. Okay, the second one is better. So basically, you have to calculate the variance, okay, and then the bias. For the second one, the bias is 0. For the first one, the variance is smaller than the other. Okay, questions? Okay. Do I need to calculate it again? Yes or no? Yes. Yes or no? No idea. Yes. Yes. Okay. Someone say yes. Okay, so in this case, we're gonna calculate okay, stop. The last question, say there are 60 students, okay? You have 60 students. Okay, and then the distribution, there to be, this question, okay, here, so you have mean, right? So mean is equal to 85, and the standard deviation is 7, so the variance is 49. So the top 5% get A, okay, so here, the top 5% get A, so actually the 5% is here. And because it's 5% here, 5% here, right? So then it is 1.64 in terms of Z, okay? And then you want to find the corresponding X, right? And then for the second one, okay, the second question say, you know, what is the mode? The mode is actually the mean, right? 85. And what is the median? Also 85, right? And if those go below 60 will be flunked. How many people will be flunked? Okay? Below 60. So here you have 80, right? And then you are trying to figure out what's the probability before 60. So P of X less than 60. And so in this case, you have P, Z less than 60 minus 80, right? And divided by 7. Is that right? Or 85, sorry. So 85. So then you have P, Z less than negative 85 divided by 7. So actually that's 3 point something, right? So it is close to 0. So that means for this class no one will be flunked, but this class is quite different from this. Okay, so